Hello everyone, I am Dr. Regina Anandi, Assistant Professor, Department of Artificial Intelligence and Data Science. In today's lecture, we will continue our discussion on asynchronous JavaScript. So this is the part 2 where we will focus on promises. In the previous lecture, we learned about callback and the problems associated with them, especially callback hell. Promises were introduced to solve these problems to provide cleaner and more manageable approaches to asynchronous programming. So let's first understand why promises were introduced. Callbacks help us manage asynchronous tasks, but as applications become complex, callbacks created problems such as nested code, difficult error handling, poor readability. So these are the callback struggles. From the developer's pain point sides like readability, unable to read, time consuming for debugging, collaboration challenges, and repetitive error handling. So these are some struggles when you're using the callback. A structured and scalable solution for managing asynchronous tasks is in JavaScript or which is described above, like sequential asynchronous operation, avoid deep callback, centralized error handling, clean and readable and maintainable code. So this is the only solution to rectify those drawbacks which we seen earlier. So here comes the solution. A promise. A promise is nothing but a JavaScript. It represents as a value that may be available now or available later or never available. In simple words, a promise is an object that represents the eventual completion or failure of an asynchronous operation. Instead of passing callbacks, promises allow us to attach handlers that run when the task is completed. So a promise can be in any one of these three states. For example, like pending, fulfilled, and rejected. Pending is nothing but an operation is still in progress. Fulfilled, the operation is completed successfully, and rejected when the operation failed, it shows rejected. So once a promise is either fulfilled or rejected, it becomes settled and its state cannot change again. Understanding these states is important to handle success and failure properly. Now let's understand promise with a simple example. In this example here, we simulate data fetching using the set timeout. After 1 second, the promise is resolved with the message data received. We then use .then function to handle the successful result and .catch to handle the errors. So this approach avoids nested callbacks and make the code much easier to read and understand. The .then function method is executed when promise is fulfilled, as I said above previously. The .catch method is executed when promise is rejected. So this operation of success and error handling improves clarity and structures. So unlike callbacks, which we have seen in the last lecture, promises allow us to handle errors in one centralized place. One of the biggest advantage of promise is promise chaining. Promise chaining allows us to perform multiple asynchronous operation which is in sequence. Here the promise is created using the promise constructor. The constructor takes a function with two parameters, resolve and reject. Resolve is used when the operation is successful and reject used when the operation fails. Each then function returns a new promise, allows the next then function to wait for the previous one to complete. This eliminates callbacks hell and keep the code linear and readable. Promise chaining is also commonly used in API calls and data processing pipelines. Promises also make the asynchronous code look like synchronous code, improving the developer productivity. Promises offer several advantages over callbacks: better readability, cleaner syntax, easier error handling, and no callback hills. Although promises are powerful, they will still have some limitations. Long promise chains can still become complex. Error handling needs careful attention. To overcome these issues and make code even cleaner, JavaScript introduced Async and Await, which we'll cover in the next lecture. To summarize today's lecture, promises solve the problems of callbacks. A promise represents the feature result of an asynchronous task. Promises have three states: pending, fulfilled, and rejected. Then function handles success and catch handles the errors. Promise chaining allows sequential asynchronous operations. Promise are a core concept in modern JavaScripts and are used extensively in the MERN stack application. In the next lecture, we will learn about the async and await, which is built on top of promises and make asynchronous code even simpler. So these are some questions, and thank you for watching this video.